Hi, this is Michelle McLean, and this is going to be a short video of an example where we're finding a confident interval. So let's look at our problem. It says a simple random sample of 8 college freshmen. So I'm going to pause real quick because 8 is going to represent our N. They were asked how many hours of sleep they typically got per night. And so here are our results. So notice that I am not given the mean, I am not given sigma. So this is information that we're going to have to find, okay? Now the good news is we're going to use our calculator to find that information for us. So I'm going to show you how to do that. But let's go ahead and read what our first question is asking. The data contain an outlier that is clearly a mistake. So if you look in here, 24, is it possible to sleep an entire day? Typically, no way. Okay, so that's what they mean. There is an outlier in there because somebody, I guess, was joking around, just not giving an honest answer. So for this one, it says eliminate the outliers. So that means we want to take this outlier out when we're going to make our calculations. We're not going to include 24. Then we're going to construct a 90% confidence interval for the mean amount of sleep from the remaining values. And we're going to round 2 decimal places, okay? So I'm going to go ahead and go to my formulas in chapter 7, which belongs to our confidence intervals. I am not given the standard deviation. It is not known for this problem. Therefore, we're going to use this bottom one to where we're going to create a confidence interval for a mean standard deviation unknown. So I don't know it. So this is the formula we're going to use. So I'm going to jot that down so you can clearly see my substitutions being made. All right, so here's our formula. So far in our problem, the only thing that we know for sure right now is n. And actually, it's not even 8 because remember, it asks us to get rid of that outlier. So n is actually 7. Okay, so I'm just going to jot that down because I know that n is 7. So I don't know x bar. I don't know T alpha over 2. Remember, this is your critical value. This is going to come from our table with a 90% confidence level. I don't know what S is, which S is the sample standard deviation, but we do know what N is, okay? So I'm going to jot down on the side here the variables that we need to find. Okay, so I'm just kind of quickly jotting this down because once I know these, I'm just going to simply plug in, put it in my calculator, and get those two values, okay? So first up, let's go ahead and calculate X bar and S. So we're going to go to our calculator, and we're going to enter in the data into our calculator. So to get to the data, we have to hit second stat, and we need to choose one variable. Right? So now that we have one variable chosen, we're going to go back to our data button and we're going to start entering in our data. So you remember you got to hit down to go to the next one. The frequency is just 1. Actually, the frequency is 2. There's 2 8.5. So if you want, you can change that frequency to 2 or not. You can enter it in twice. It's up to you. So let's see, 7.5, 6.5, 9. We skipped 24, 6. I already put in a frequency of 2 for 8.5, so let's put in 8. Okay. You can hit equals. It really doesn't do anything. But up next, we want to hit stat var, and it's going to calculate the information for us. So you can see we already have our n of 7, which is good to double check because now I definitely know all 7 pieces of data was entered in. I'm going to scroll over. Here's my X bar. The problem said round 2 decimal places, so let's go ahead and round this one 2 decimal places as well. So 7.71. And I'm going to go across to that is my standard deviation of the sample. So this is 1.11. All right, so my calculator gave me everything I need to know for now. So I'm going to go ahead and move that off. because now I need to go to my table. So for our tables, we're going to use the student's T distribution table. And of course, since we didn't know sigma, that means we're not going to do the bottom Z. We need to do degrees of freedom. Degrees of freedom is n minus 1. So n minus 1 in this case would be 6. So we want to do 6 with a confidence level of 90%. So the way that I like to do this is I actually like to start from the bottom. So 90%, and I'm going to go all the way up until I hit 6. So at 6, it's 1.943. Right, so that's the value we are getting for 6, 1.943. All right, so now that I have all of my variables, now I'm going to plug it in, and I can calculate this in my calculator. So our point estimate is 7.71 minus our critical value, 1.943, times our standard error, 1.11, all over square root of 7. So remember, we call this the point estimate, and this is our margin of error. And then, of course, we want the exact same thing on the right-hand side, except now we're going to add. I'm going to rewrite this, and instead we're going to put a plus sign. So now I'm going to go to my calculator. Let's go ahead and type this in. 7.71 minus 1.943. Open my parentheses, 1.11 divided by square root of 7, and we close our parentheses twice. So when I hit equals, I get 6.894. It's a round to 2 decimal places, so that's 6.89. That's going to be our left side of our interval. Right side, remember calculator trick. I'm going to hit my up key, and I'm just going to change the minus to a plus sign, and that gives me 8.5, and that 2 is going to round up to 3. And so if you look at your values, that sounds about right for the normal amount of sleep that you should typically get. And you can kind of see it's close to the range that our data is showing. Okay, so what does this mean, the interpretation? We are 90% confident that the mean amount of sleep for a college freshman falls between the intervals 6.89 hours and 8.53 hours of sleep. Okay. Now let's look at part B. It says leave the outlier in and construct the 90% confidence interval. So we are doing a confidence interval, same exact formula, but all of our values are going to change now because my n now is 8. We're including the 24 that we excluded for part A, sorry. X bar, we're going to have to recalculate. The critical value, we're going to have to recalculate. And of course, the standard deviation S, we're going to have to recalculate. So I'm going to go to my calculator. And I still have the stats in here. So I'm going to hit my data button. And you can see I've got the 8.5, etc. So it's all in there. So I'm going to go and I'm going to scroll down until it lets me start typing in. So see how now it's letting me type in. So I'm going to tack on that 24. And now I'm going to hit my stat var. So look, now n is 8. So that's good because that means it's calculating all of them. X bar is 9.75. So let me come over here. I'm going to scroll over to S, which is 5.85. Now let's grab our critical value. Remember, we need to do degrees of freedom. So 8 minus 1 gives us 7. So we're going to look for a degree of freedom of 7 with a 90% confidence level. So 90% here. I'm going to go all the way up until I see 7. And I'm going to stop. So 1.895. And that is our critical value. All right, so now I'm going to plug this in. So our point estimate, 9.75 plus and minus. So I'm just going to, I'm going to combine this into a shorter version of the formula. We want to do 1.895. That's our critical value times our S, 5.85, over the square root of n, which in this case is 8. Okay, so we want to add and subtract this. So that's how, if you don't want to rewrite this whole thing, you can just shrink it down. All right, so 9.75 plus 1.895 times 5.85 divided by square root of 8, close parentheses twice. And when we hit equals, we are getting the value 13.67. So I did the plus first, so actually that should be written on the right side. Let me erase that. Of course, mu is going to fall in between. So calculator trick, don't erase. Hit up, change your plus to a minus, hit equals, and that gives you 5.83. So we are 90% confident with all of the data being given that our mean is going to fall between these two values. Okay. Last part, are the results noticeably different? Well, I mean, the left side isn't too bad. It's about an hour difference, but look on the right side. It's about 5 hours different. So to me, that is a big difference. So I would say, yes, there is a notable difference. I mean, the only time I would say no is if, these values on both sides needs to be much closer in range together. But this is a huge jump. Therefore, yes, there is a notable difference between the two. Okay, so this is how you find a confidence interval where you are given data and you have to find that interval. Last thing before I shut this video off is whenever you put in data in your calculator, make sure you hit second stat var and make sure you exit out of that data. So it's clearing it out and it's prepping me for the next set of data for me to enter in my calculator. All right. So if you've got any further questions, feel free to email me.